Hello everyone. Today again we are going into another video of calculus. Here today I will be showing you why ddx of log x equal to 1 by x. I shall prove that using the first definition or using the help of limits. And secondly also why ddx of x to the power n is n x to the power n minus 1. That I shall also show you through the first principle, that is using limits. So let us start today using the first one, that is why ddx of log x equal to 1 by x. Now you can remember in some earlier videos I have shown you what is meant by first principle of derivatives. Now ddx of log x can be written as, if I express them in limits, as limit h tends to 0 log of x plus h minus log x whole divided by h. Right? Because our formula says that limit h tends to 0, f of x plus h minus fx by h is the f dash x. So what is log a minus log b? We know that from the basics of logarithm that log a minus log b equal to log of a by b. Right? So here log of x plus h minus log x can be written as log of x plus h divided by x. So the same expression is converted as limit h tends to 0, numerator becomes log of x plus h whole divided by x divided by h. Now I divide the x plus h by x, so it becomes limit h tends to 0 log of 1 plus h by x whole divided by h. Right? So here you can understand that h is also a constant, but here I will be doing one thing. I will be just dividing the denominator by x, and to keep the balance I am multiplying another x in the denominator. So what my expression becomes, I can take it as limit h tends to 0. Now the entire limit is evaluated on the variable h, not x. So 1 by x I can take out of the limiting expression. So 1 by x limit h tends to 0 log of 1 plus h by x whole divided by h by x. Right? Now if h tends to 0, then it is obvious that h by x also tends to 0. If h by x is written as y, then that means y also tends to 0. So what is the expression now? Now the expression becomes, it is 1 by x is already outside of the limit, limit y tends to 0 log of 1 plus y whole divided by y. Right? And this is by the first principle of limit is 1. So the only remaining expression is 1 by x. What is the value of this? That is the value of this 1 by x. That means by first principle using limits I can derive that ddx of log x is 1 by x. This is number 1. Secondly, I am going to the second problem that I have shown in the beginning of this video. What is that? By first principle or using limits, I have to prove that ddx of x to the power n equal to n x to the power n minus 1. Now from definition it is limit h tends to 0 f of x plus h. If fx I can write it as x to the power n, then obviously f of x plus h will be x plus h whole to the power n minus x to the power n whole divided by h. Right? Now I have to do a polynomial extension of the expression x plus h whole to the power n. What is that? That is limit h tends to 0 x to the power n minus 1. Sorry, x to the power n will be the first term. Then it will be n into n minus 1 by 2 into x to the power n minus 1 into h plus n into n minus 1 into n minus 2 divided by 3. This is 2 factorial, this is 3 factorial, and then it will be, the coefficient will be x to the power n minus 2 and it will be h square plus up to so on up to x to the it will be h to the power n minus x to the power n, right? So the entire expression of this polynomial is getting expanded like this way, minus x to the power n whole divided by h. Now if I remove the bracket, you can understand x to the power n and x to the power n, they are nullified. So the only expression becomes this way. So here is a one problem that I have written here. So the expression will be, I am just repeating the expression over here. Here the expression will be limit h tends to 0, x to the power n, I am expanding it once again, plus n into x to the power n minus 1 into h, that is x plus h whole to the power n is expanded this way, plus n into n minus 1 by 2 into x to the power n minus 2 into h square plus so on, plus h to the power n minus the last one, that is the x to the power n whole divided by h. Now x to the power n and x to the power n, both these two terms are nullified. So the pending terms is n x to the power n into n x to the power n minus 1 into h plus this one, this one, this one. So limit h tends to 0, for this term h divides h, so it is n x to the power n minus 1 plus n into n minus 1 by 2 x to the power n minus 2 into h plus all terms plus something. Last term will be h to the power n minus 1, because h to the power n whole divided by h is h to the power n minus 1, that will be the last term, so on. So this term is devoid of any expression involving h, so I can take it out, but rest all the terms having h or any power of h. Since h tends to 0, anything to the power 0 is 0. So all the remaining expressions except the first term will be 0. So my final answer will be n x to the power n minus 1. So these are the two basic examples of deriving the derivative of algebraic or trigonometrical or log anything using the first principle or limits. If you like this video, I would request everyone to view, watch and subscribe my channel as well. Thank you.